Hello all, welcome to Code Hub. Today let us solve the LeetCode's daily challenge. Design circular queue. Design your implementation of the circular queue. The circular queue is a linear data structure in which the operations are performed based on FIFO, first in first out principle, and the last position is connected back to the first position to make a circle. It is also called a boring buffer. Okay. One of the benefits of the circular queue is that we can make use of spaces in front of the queue. In a normal queue, once the queue becomes full, we cannot insert the next element even if there is a space in front of the queue. But using this circular queue, we can use the space to store new values. So implementation of the circular queue. Whenever this my circular queue of k is called, k it is the size of the queue is initialized to k. In front will give the item in front of the queue, and rear gives the item in rear of the queue, last element of the queue. And if it is empty, we have to return -1. So boolean enqueue, the value is called, then it will insert the element, and if the enqueue operation is successful, it is going to return me true, or else the same applies dequeue. If I can delete an element in the circular queue, I will just return true if the operation is successful. And this is empty and is full returns true and false based on their respective functions. You must solve the problem without using a built-in queue data structure in your programming language. So as they said, we cannot use a built-in queue data structure. So what we can do is we can use a vector or array to initialize the size of the queue. So I will use a vector of which is initialized with the size of k. So let us do the example. Write run the example. Whenever a queue data structure, where we have to insert a particular element either at front or either at rear. So what I will be doing is I will going to insert the element at rear position. So for that I have to have two variables. Front variable is initialized to -1 initially, and rear variable is also initialized to -1. If front and rear is both are -1, then the queue is not full. So if the queue is not full, then what I can do is I can make the front to be 0, and I can just add a particular element. Add the element at rear position. Element at rear +1. Add the element at rear +1 position. And I will give the analysis itself. The circular queue of size 3. So initially the initially have a vector of size 3. As you can see, the k is 3, and my front is -1, and rear is also -1. So what will be the full case? If the queue is empty, whenever a enqueue operation is called, if my front and rear is both -1, then what I can do is I can initialize front to be 0, and then rear +1. I can add the particular element at rear +1 position. So 1 is added at 0th index. At the 0th index. Next, again the 2 is called. So again the enqueue operation is called with the element 2. So I have to insert 2 into the queue. So for that, what I can do is I want to check for whether the queue is full or not. If the queue is full, I cannot insert any element into the queue. So what will be the condition for the queue is full? Condition for the queue is full. How I can say? If my rear +1 is equal to my front, then I can say the queue is going to be full. Queue is full. It is not going to be full. It is queue is full. What is the condition for queue is empty? Queue is empty if my front is -1 and rear is also -1 and rear is also -1, then obviously I can say that the queue is empty. So what I can do is again the particular element q2 we want to be inserted into this position, and since rear has become 0 after inserting the 1, so now rear plus 1 which is not equal to front, so I can obviously insert 2 into the queue, and I will move rear to 1, and now my rear is 1, and again the enqueue operation is called with the element 3. So rear plus 1 which is 1 plus 1 which is 2, 2 is not equal to front, so I can obviously insert 3 into the queue, data queue, into the array, and then I can make this rear to be 2, rear to be 2. Now the queue is full, as you can see that queue is full. Whenever useful is called, you can see that 2 plus 1 which is 3, 3 mod k which is 0, 0 is equal to this friend. So our condition for full is true. So next NQ operation is again called with the element 4. As you can see that the queue is already full, I cannot insert that particular element into the queue, so I will be returning false. Next, the rear is called. What is the functionality of the rear? If I call rear, I should get the last element from the queue. If the queue is empty, return -1. So rear is nothing but the element which is at rear position. So rear is 2, so the element at 2 is 3, so I will be returning 3 as my answer. Next, is full is called, yes, or the queue is full, so I will be returning true. As you can see, the true is returned. How the queue is full? Rear plus 1 equal to front, so it is true. Rear plus 1, I will be more precise, mod k, so that it will be easy, is equal to front. Okay, now the dequeue operation. The dequeue operation, what is the functionality of dequeue operation? Deletes an element from the circular queue. Returns true if the operation is successful. So what is the element first in, first out? So 3 is added first. Sorry, 1 is added first. So now the deletion is happening in the front of the queue. Deletion always happens. Deletion always happens in the front pointer. Front pointer. And insertion of element always happens in the rear pointer. So that is what you have to understand first. So my front is at 0. Since front is at 0, I can just say the particular element which I want to delete is 1. So I will return 1. Since I can delete one element, I will be returning true, and then front will be moving to 1. And then again if I call insertion after dequeue operation, they have returned true, since it was deleting 3, deleting 1, after which the enqueue operation is called. Enqueue operation is called with the element 4. As you can see that 2 plus 1 which is 3, 3 mod k, 3 mod 3 which is 0, 0 is not equal to 1, so q is not full, so I can insert an element 4 into my queue, and my rear will become 0 now. So now the queue is full again. If I call rear, what will do the rear will do, give the element which is at rear position. So 4 is at the rear position. I have returned 4. That's it. So hope you understand this. What if the queue is empty? If now consider we are calling dequeue operation, again dequeue operation. We are calling 3 times dequeue operation. So I will first delete 2, and my friend will be moving to second index. And as you can see that again I am calling a dequeue operation. So as you can see that friend front is at the second index. I have to delete 3 and the operation is successful, and then front will become front plus 1 mod k, which is 0 now, and I have deleted this 3. And then what I'm doing is again calling a DQ operation, and you can see that front and rear is at same position. So what I have to do is, if my front is equal to rear, then I can just set front to be -1 and rear to be -1. Front and rear equal to -1 as the queue is empty. If the queue is empty, that's it. The element again the queue insertion is again the deletion is successful. I'm obviously returning true. So hope I have handled every cases. Let us code the approach and see whether it is getting done. If you didn't understand what I'm doing, you can just go back and watch again. You will get an understanding. First, first I will create a vector of int q. I will name it as q. Whenever this constructor is called, I should resize the q data structure with the size k, and I will initially have it as 0. I don't want to initialize with 0 everything, but yeah, I don't want to initialize it. I also need 2 pointers in front and rear. Whenever this constructor is called, front is -1 and rear is -1. This indicates that the queue is empty. This indicates that queue is empty. That's it. Okay. Now we will fill the what will be the is empty and full case. Is empty is nothing but if front is equal to -1 and rear is equal to -1, then I will return true. I can just say like this. If my front and rear is also is -1, then it will return me true, and you can say that the queue is empty. What will be the case for full? The case for full is I also need a value k, right? I will say it as size. The size will be initialized with k. So what will be the case for full? Rear plus 1 mod k is equal to front, then I will say that queue is full. Return rear plus 1 mod k. Mod k is nothing but the size of the queue. If this rear plus 1 mod size is equal to my front, then obviously I can just return true because the queue is full. Okay, I have finished these two functions. Now let us focus on this enqueue operation. We can, before going to enqueue operation, we can just finish this front and rear also. What I can say is, if I call a friend, I should have an element first. If my queue is not empty, if not of is empty, if queue is empty, then I will just return -1 because they have mentioned that whenever if the queue is empty, I will be returning -1, or else I can just return the element at the front position. So I will be saying queue of front, return queue of front, as simple as that. And what will be the rear? If it is empty, if the queue is empty, return -1 as said by the functionality, and or else I can just return the element which is at rear position. Superb. So we have completed these two functionalities as well. Now let us focus on this enqueue and dequeue operation. So what is the case if when I can insert an element into the queue? If the queue is not full, only I can insert. if the queue is already full, if it is full, then obviously I can just return false, because I cannot insert the particular element into the queue. Or else I can insert that particular element into the queue. How I can insert? I'm going to insert the element at the rear position. So queue of rear plus 1, sorry, rear plus 1 mod size. Mod size, why? It should not overflow, it should not cross the boundary of the size of the queue. So I'm just taking the mod size and just value, assigning that value. I can have this as another variable itself. Rear becomes as rear plus 1 mod size, and queue of rear is nothing but the value, and just return true. But I have to handle one case. If my initially the queue is empty, in the sense, if my friend is equal to -1, then obviously I will make the friend to be 0, or else friend will be pointing to -1 itself, so it should not be the case, right? So this is our enqueue operation. So we have successfully inserted the particular element into the queue. So what will be the deletion case? If this is empty, that is deletion. DQ deletes an element, return true if the operation is successful. If I cannot delete an element, if the queue is already empty, if em is empty, is called, if it is returning true, then I can just return false, because I have not done this operation at all. Okay, super. If the queue is empty, I am just returning false. Or else the queue is having some number of elements, so that I can delete the particular element at the front position. So what I'm doing here is I will just move the friend. I am hypothetically moving the friend pointer, so that I'm saying that I have deleted the particular element in that queue. So what I'm doing is I'm just moving the friend pointer. Friend becomes friend plus 1 mod k, mod k, mod k in the sense size. Friend plus 1 mod size, that's it. And just return true, but we have seen one case there. If my friend is if there is only one element in the queue, if there is only one element, the size of the queue is also 1, and we have inserted that particular element in the queue, consider it, and I have called DQ operation. DQ operation in the sense, friend will be moving one position. That is, if my friend and rear is at same position, that indicates I have only one element in my queue. What I'm meaning is, if my friend if friend is equal to my rear position, then there is only one element in the queue. So which is nothing but, if I'm deleting the element from that queue, the queue becomes empty. Empty in the sense, I have to reinitialize front and rear to be -1. I hope you get an understanding. So if my front is equal to my rear, then I will reinitialize front equal to -1 and rear equal to -1. Else I will be doing this case. I will be moving this front pointer alone. Hope I am making it clear. So we have done the each functionalities. Let us try to run the code and see. Hope it should work. I may be missing in some case, but it should work. Oh yeah, it's working fine. So let us run the code. I will give a small walkthrough of the solution. We have initialized the circular queue. the enqueue operation, we have not, we have only one case to see. If the queue is full, I cannot insert that particular element. Or else, if my friend is zero, friend is -1, I am saying that friend is the queue is empty. So I will reinitialize friend to be 0, and then I am moving one position rear, and then I am inserting that particular element in queue. In dequeue operation, I am checking whether the queue is empty or not. If it is empty, I cannot delete an element. Or else, if my friend is equal to rear, then there is only one element in that queue. So I will reinitialize front and my rear to be -1. Or else I will move the front pointer. That's it. And I will just return true. What I'm doing here is int friend. I want to see whether the element is present in queue. So if the queue is not empty, then I will return queue of friend, or else I will return -1. Here also, if the queue is not empty, I will be returning queue of rear, or else I will be returning -1. Here, if the queue is empty, I am just checking whether the front is front and rear both -1. And if rear +1 is equal to front, then I will say that queue is full. So these are the conditions, and hope you like the solution. Let us try to submit the code. It should get accepted. Hope you like this video and it is getting accepted. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.